Who are we missing in the panel? That's Damir and Ramondas. Yeah, that's true. While I'm standing here and entertaining you, all of you, I will do like the Nordinet director always does when we are having what we call all hands, where everyone from Nordinet is gathered. He starts with saying, no laptops, no iPhones, no playing devices, no nothing. So everyone, please attend. I'll just say the same. So an entire day without your phone and your laptop, that's interesting. So I think we are more or less ready. We talked about having some kind of panel discussion. It was more a discussion where we would like actually to bring all of you into this discussion to come up with some ideas. There were some stickers on the flip chart, and I had taken my chance to convey them into a piece of paper which I could actually read. I had some help from Henrik. So there's a set of topics here. And what I would suggest is that, of course, we have this really nice panel, intelligent people sitting here in first row, and what I would do is I would put the questions forward, and of course they can answer. Some are more specific, directed to Sienna. But again, as I said, I'd like you all to be a part of this discussion. I have, should we call it, 3 main areas. One is directly related to IP. The second one is switching, meaning layer 2 primarily, and also the optical layer. And then there is a couple of questions related to software-defined networking. So before we start, does any of you have any additional things we should put on the board right now, or should we just take it as we go along? Okay, nothing. So, if we start with the IP part, one of the trick questions here I would say is what gives the panel any confidence that we can migrate to a new network architecture when we haven't been able to deploy IPv6 for the last 20 years? And an interesting question. So I think we should start here in the end with Damir.
Well, it's an interesting question, but I think it's a question for everyone because you're all running their own network. So why IPv6 is not working?
It is.
Yeah. Well, it is working in practice, but nobody is using it. Why?
Because I think the content providers.
We need it.
I think the content providers are not running IPv6, or some of them are running. If, for example, let's say YouTube tomorrow said, okay, we'll only show you video if you use IPv6, I'm sure half the world will move to IPv6. But it's network. A giant network has been running IPv6 since 2004, so networks are ready. And if you look at the experimental side, I know that LHC site, for example, they all use IPv4. Even they're not using IPv6 because their applications are not ready for IPv6. So that's the problem.
Yeah, I would like that one, because basically IPv6 does not give you anything in exchange. And for example, and maybe on the other hand, and the network architectures have changed since the invention of IPv6. ATM was there and it's gone. MPLS was there and it's almost gone. SDH was there and it's already forgotten. So underlying network technologies have been changed regardless of IPv6 implementation. And I don't think there's any need to push any technology specifically without the ultimate requirement from the users, from the content providers, from cloud providers, or from the network providers.
But now you have requirements for IPv6.
Yeah,
You don't have any more IPv4 addresses.
yeah. So that's
switching.
no, that's a point in time when IPv6 will happen. It is happening now because most of the computers, most of the end devices, they do have IPv6 already enabled by default. And if you are not disabling it, it is still enabled and it is working. And what gives the confidence of new technology if IPv6 has not been implemented? It's not a question that is somewhat relevant, because IPv6 was not immediately and ultimately required, and the patchwork of workarounds was successful enough in the meantime before the end of IPv4 before the actual end of IPv4 address space. So that's only now that IPv6 is starting to being enabled, and it will happen as soon as somebody who will become a new Facebook or a new Dropbox or whatever will choose not to deal with the headache of IPv4, and will say we are. It's always the problem of the if they will have the mass and the speed of rhinoceros. It's not their problem that they will be using only IPv6. And then people start. Well, basically, it will trigger because now it is supported. Technology is supported. Allegedly, it's supported, and that's all. So it's not really. SDNs are a bit below, and these SDNs and the new design of the network switching and so on is one of those technologies who were implemented and may be implemented regardless to IPv6.
I have a slight divided view. I've also heard for the last 20 years that more or less the same, that now, even though we have all the patches on the addressing thing, then IP version 6 is they cannot do it anymore, and now IP version 6 is needed. And but I also heard that for the last 10 years. But on the other hand, I also believe that it will come and well, it is simpler, it is nicer, and with Internet of Things, that I see no way around it, except that you have a massive use of private address spaces. But if we go back to the question, I see a lot of things about future network architectures that has something to do with the quality of service and things also below the IP layer. So I think there's a lot of things that can be done there, regardless of whether it's IP version 4 or IP version 6 or IP version 7, or whether it is some kind of recursive simple layering model.
I'd just like to add that it's a very good question. I do think that it will be difficult to, it doesn't give me at least a confidence that we'll be able to move to a one future architect when we know IPv6 have developed many years ago. It's been supported in all the equipment since early 2000s, late 99, and we still haven't moved. So we haven't agreed on any future architect. So I think we'll still have to have discussion what is the future architect before we decide that we will move to it or not.
I would not agree that IPv6 is supported in all the equipment.
Majority of the equipment now is supported.
Really?
Yeah.
Really? Think of the access switches. it does not matter if you support IPv6 in the core. IPv6 is supported in the core for 10 years or more, but it is not used because the access network does not support it. So how many switches do you have to support router advertisement guard, for example, or network neighbor discovery cache overflow? So there are not many equipment still there which support IPv6 deployment up to the end devices. So it's it's not that simple.
Yeah, you can, yeah, of course. Please.
Well, if I think I agree with the point of the address space not running out yet. I mean, sometimes you see press releases where people sell a certain IP range. I think Surfnet also announced that a few years ago, that they transferred one to KPN. But I guess it's not that urgent yet, that people are forced to actually use IPv6. So that's why IPv4 seems still to be sufficient in most cases. So.
And on the other hand, it may happen that there will be no new technology, like no new underlying technology, even like SDNs or something, but rather the patchwork of existing some workarounds to be able to achieve the same functionality that we are looking into with the SDNs.
Okay, thank you. Now that you, I have this audience. I was going to ask the audience if, or you guys, if you had some questions related to this.
I think that implementing and using IPv6 is not only a question of the network devices that have to support it, but also on the application side of view, there are configurations that has to be done into servers, DNS, and all the surrounding environment. And when some organization have a working IPv4 network, they will not invest so much on adding IPv6 unless they have no choice. So this is a problem. This is the reason IPv6 was not implemented fully.
Well, I would like also to ask the Janet guys, especially you, Rob, if you have a comment on yeah? Because I know that you have comments related to this, so.
Well, from what I understand from talking to the person that asked the question, you've now explained why V6 wasn't adopted. Why would any new network architecture be adopted? I mean, the internet works, apparently. It's quite successful. Why is there a need for a new network architecture? What would drive the adoption of a new network architecture, especially on the timescales that you were describing for Arena of maybe 2017, 2018, which is 4 years away. 4 years away.
There are drivers. I would say that the data paths have changed, and the way the internet has been used is changing, in a sense. The number of access devices is increasing and will increase, and also the need from the service from the carrier. There is a need to provide a different service rather than it was before. So it's no longer a matter of IP co-routing than it to be provided, basically to be based on, but maybe it's something different, like cloud interconnect or something.
I might add that we are getting used to the internet everywhere now, And that also means that we begin to incorporate into the more critical application, for instance, telemedical application, and then we're talking about quality of service, and then we have a drive for something where we have basically have been used to that. Oh well, it works most of the time, nice, and of course also especially in research environment, it actually works good because we have a massive over provisioning. And then we can discuss whether over provisioning is the way or whether there are other ways. But still, also when you're going to the end mobile, we have some collaboration with some doctors and some medical people who say that they cannot do the treatment correctly simply because they often have too many artifacts that coming in and no reliability, no quality of service in the applications, and these are now critical applications that we are somehow have the idea the internet can solve that. So I think the applications can be the drivers for something new.
Yeah, and I think also, I mean, if you look at each of us, we're using tremendous amounts of data if you compare it to like 10 years ago. And more, like if you look in the commercial world, for example, people are not receiving any revenue, almost no revenue for those large amounts of data. So up till now, maybe, you most of the time could get away with over-provisioning, for example, but I think in the long term that will be too expensive. So you have to move to a more efficient network with more dynamic bandwidth allocation, I think.
So are you saying we came to the limit? We came to the limit of maximum bandwidth that we can produce. Is this the limit coming soon, or?
I think in terms of, for example, the terabit per second experiment that I showed, we also did a 2 terabit per second experiment. And if you compare that to the nonlinear Shannon limit, where you include nonlinearities, I believe that was about 5 dB away. So, but it depends on, with time comes new technologies, maybe better FEC algorithms, so it might change again. But when I was in a university, they said, fiber has unlimited bandwidth. And it seems, we are kind of seeing the limit. It's at least coming close, yeah.
And on the other hand, if the technologies have been were being implemented in the network, those technologies which require least, so to speak, least effort has been implemented in the network, and so far, otherwise, network is being slow to implement any new protocol, and IPv6 is a good example of that. So what SDNs may bring is that they may change the task of something implemented into the network from devising a new protocol and standardizing it and putting up, rather than programming a new software system inside the controller which can implement this particular function of the network. So, yeah.
Okay, that was the first first question. I have a lot of questions here. So I think some of you touched base on quality parameters, the switching layer. So I think we should try to move along and move into the switching layer, and I'll try here to see if I can combine all these questions regarding switching. One of them is stated like, is it better to tie the switching layer to the optical layer or to the routed layer? And adding to that question, I would say, what type of technology, when looking at the switching layer, should or will we use? Would it be OTN based? Would it be carrier grade Ethernet? Would it be MPLS, TP, whatever? What are your comments on that? Should we start from an end?
Okay, so I just presented on convergence. So we converge switching layer with the routing layer. So I'm going to say it's better to do it that way. And the reason for this is because we think if we have two different networks, one for IP and one for switching, be it at OTN level or layer 2 level, we'll be running two different network, managing two different network, and over provisioning both. So if we merged it with switching and IP layer together, we have single big pipe 100 gig, and we just manage those rather than having SDH or OTN layer as well. So that's why I think it is better to do IP and switching. The other thing obviously is with the if you're doing IP MPLS based switching, it gives you more services. It gives you layer 2 point to point, point to multi-point, layer 3 VPNs as well you can support. So it gives much more range. So I think it's better to do routing and switching.
I would agree that the packet processing should be merged into one layer to avoid the layers and sublayers of and the complexity of the network. So I would say routing should be glued to switching.
For each layer, they have different granularities. That's for sure. What might be in conflict with that might be on whether it's too energy consuming to do too much in the IP layer. I do not have the answer for that, but it's just at least an input that could, doing this lookup in IP, can they be more complicated than looking up other places and so on. But that leads you to the Shannon thing.
Yeah, I think I agree with that point. I mean, if you do all the, for example, all the coherent interfaces, if you would do them in a router, I mean, at least at this moment, you would have a thermal power problem, I think, still at this time. So you would maybe be limited in terms of the number of the capacity you can get out of the router. While if you use short distance interfaces, you may not, and do the WDM elsewhere. And as far as doing everything in IP, as I showed in the presentation, I think in terms of transit traffic, it may be beneficial to just not pass that through the router at every point if the traffic does not need to go there, but just pass it on as an optical wavelength. And then in terms of the question on switching, you could do OTN, you could do packet. Actually, we see demand for both depending on the application. So we don't really choose either way. We see market traction for both, actually, OTN and packet. So
I would generally agree with your last term. The market should decide. Yeah. Personally, I'm the IP guy, and I'm fan of MPLS. So MPLS will adapt. You have GMPLS that is still not used properly. So it combines the best of all the worlds. So is this the future? I don't know. For me it is, but I'm not the transmission freak, so.
So, of course, I will again turn towards you guys, and my eyes are looking at Victor or Kuros. Do you have a comment on this?
Not much, but I think I saw both implementations. It depends on the, I think, vendor specific. So IP vendors, they use MPLS, and optical vendors, they try carry Ethernet probably like a switching technology. So, well, I can't say I see any strong benefits for each approach. So, no, it's my opinion.
I guess it is very depend on what kind of product portfolio the operator or the airline have actually. If you have only IP connectivity, IP based services, so it is better to have switching and IP layer merge in rather than do it on the OTN level. But if you have a broader product portfolio and sell a lot of maybe dedicated bandwidth with QS, some other kind of services, then it's better to have it on the lower layer, because to run all this capacity on IP layer, it will cost a lot just in terms of transfer it actually. If we go back, for instance, to we thinking that even if STH is dead, but it's not actually. If you go to Italia Telecom, they built a new network, brand new network this year based on photonuclear, but also they introduced audio switching level, but also actually they introduced NVC switching level. And the reason for doing that is that they are saying that they have a lot of still a lot of 2 megabit per second leased line services, which is not, they can't actually run it either on audio switching level or on PLS level because it's so costly. They cost a lot. So actually they introducing switching level in 3 different levels, maybe on 4 different levels, both MPLS, VC switching, audio switching, and also on wavelength switching. So it's actually no one question. You haven't one answer to this. Much depends on what kind of operator or what kind of business you are running.
I think we should move more into, still in the switching layer, looking into timing and synchronization over the networks, the need for that support. This is a specific question towards Sienna. So time and synchronization over networks, support of synchronous Ethernet or PTP. Does that ring a bell to you, Roland?
Time protocol, PTP.
No one stated this question.
Actually, precise time protocol, I'm not that familiar with it.
But just still on the synchronization and timing, I know that you, Henrik, in Gen3 were running this subtask called time-sensitive data. Are there anything that speaks for a certain technology? When, for instance, talking about video, you are talking about medical as well, or other type of business that, or do you see actually anything, or could you elaborate a little bit on that?
Well, any applications can, I would say, the applications that we investigated, maybe with one exception that I'll come back to, can run on any of the layers, provided that there are no congestion, no other traffic. The only thing which really needed this extremely low was something that the NRENs are not into, but it's about the stock exchange trading, this algorithm trading where millisecond counts, and there was a quote that I saw from the Daily Telegraph that each millisecond for a big hedge fund was worth 1 million, or was it 100 million? I don't recall, but it was a lot. But that's just from a symptom of a sick world. But it's a nice driver, of course, and we should be happy with that. But otherwise, the point is just related to the previous question. Also, what Courage mentioned, that for most of the applications, normal applications, a couple of millisecond difference is usually not making much of a difference. Of course, if there are some synchronization of atomic watches and so on, it might be different. But I have no experience with exactly that one.
Yeah, so maybe on the comment of latency, well, the data that I showed where you can actually change the amount of FAC that you do on the line will change the latency, and that is interesting for that market. So where they actually are hunting microseconds out of the line. I mean, there's every year there's a WDM conference in Monaco, and a few years now somebody from the New York Stock Exchange has given a presentation there, and he was hosting their data centers, and it was so critical that people would actually, they would have to add patch fibers, so everybody had the same delay to the router or the access switch, whatever, to put in the order, so it's exactly at the same time. So that is indeed a very, very special market, and so in that sense, you know, changing the latency of the devices would help those guys. I mean, there's other things are important, like they also like the fact that you don't have dispersion compensation anymore. So that is also, of course, a fiber length, which is an additional delay that you can take out in coherent systems. And other things like you don't need the amplifier anymore to compensate for the loss of dispersion compensating fiber, because the amplifier also has like 30 meters of erbium doped fiber. And that goes really into details. And but that's a very specialistic market. But yeah, for some reason that's worth, some people that's worth a lot of money. And then in terms of timing and synchronization for like atomic clocks, I've seen some projects on that. I think Chestnut is working on it. And maybe Joseph can comment also. But yeah, that's very specialistic when you get into the really high accuracy clock transport, because you need to do bidirectional transport over one fiber, so you can actually cancel out the fluctuations in the length of the fiber. And that is something very specialistic for which there is a very small market. And I think at this moment we're not working on that yet.
Wait a second.
Monitoring grid networks, what are their requirements are?
You mean like power grids?
Yes, I heard that actually their latency cannot be higher than 1 millisecond if you control and monitor power grid, the high voltage core network, let's say. Do you know anything about that?
I don't know the exact specifications for the latency they can tolerate, but I know it's an important parameter for them, especially if they switch from one network to the other. It really has to be synchronized, because if it's not, then bad things happen in high power networks. So it's really critical. I don't know the exact spec, but I would think, I don't know if Google is your friend in a way. So I think there should be some information on that over the web. But yeah, I think you're right. It's very critical. Yeah.
Susanna had. You had a question, quick one. Yeah, I thought you would.
It was not my question. I think it's not such a specialistic market. I think it's, I mean, Kurosh probably wouldn't agree, but the SDH market, if it really goes away, a lot of applications have been depending on the framing reference. And if you replace SDH with Ethernet, you don't have that information anymore. So a lot of applications are going to come up and say, wait a minute, we need some kind of clock reference, we need accuracy, and this is something that should be supplied in the network so that we all have the same time signal and the same time stamps for whatever applications we need and run. I know that Juniper, for instance, offered. That's probably why the question came from the audience, if Sienna switches have things like synchronous Ethernet features or precision time protocol enabled.
I think you can. Yeah. If you speak loud, they will.
Yeah, that I have to admit, off the top of my head, I couldn't say which switches exactly support it, so I have to check it. I know some do, but I would have to check on that. I don't know off the top of my head. Sorry. Yeah.
I might make a little correction to myself. In the time-sensitive transport, those applications we looked at there, we didn't find any except for the except for this stock exchange, where the delay for the end application was extremely critical. But for the synchronization in the network, of course, it is an important parameter, and I agree with Susanne that taking out the SDH means that we need to provide the synchronization in other ways. To clarify.
You would have a question, Josef?
I definitely agree with Henrik that for synchronization the delay is not essential. Essentially stability or uncertainty. It's that's good. And sorry Tony, I use another 20 seconds. Let's say definitely. And again, it depends on stability you need. If you need stability like 10 to minus 12, you have to use, as Roland mentioned, some really weird bidirectional transfer. If you are fine with 10 to minus 6, okay, synchronous Ethernet will work perfectly. That's all. Thank you.
Any more questions related to the switching and the time synchronization and stuff like that? Because I think we'll round things off with just talking a little bit about SDN. And I have a specific question for you, Roland. Could you please talk about your OpenFlow portfolio? And it's in brackets here, spec 1.3.
No. No, it's...
You can shoot you afterwards.
No, I would have to talk to one of the SDN experts in Siena on that one. That one I'm not familiar enough to, especially the particular release.
The last one here is how do the industry see this? This is related to SDN, the control of their hardware. Perhaps also a question for you, meaning that you are giving up the control of how your hardware is actually used. And then just for the rest of the panel, just to comment on that after.
Yeah, so we some vendors actually do kind of talk about SDN, but you can still hear that they really would like to keep it within their single vendor environment. And we as Siena, I think we have to work together on the SDN, and we have to allow this control of our equipment in this way, and that's what we're working towards. So in a way, it's then going to be the user who can talk to all of the equipment from the different vendors and manage and configure the network. But that is the way we are at least going.
Any comments to that?
Well, I know we were in our task also looking at the SDN. What I personally see, SDN is the future. Well, what you are doing with the SDN, you are replacing one person who is configuring all 100 routers with one application who is doing that. So who is the faster one? The application is not just configuring, he's setting up some kind of new rules, new intelligence to the network. So for me, this is the future. So probably we are going to lose our jobs because the application guys are going to control the network. The application will control the network. We'll set up some kind of rules to the network. I want this kind of bandwidth, this kind of jitter, this kind of... So this is the future. So.
Well, also when we tried to look at into the SDNs, and the first and the essential thing about the SDN is that you change basically. If I it's not a speakerphone, so okay. So if you change, it's a change of philosophy from protocol to system programming. If you need some functionality of the network, some specific functionality of the network, like forwarding some traffic, or it's a classical example, the recasting or whatever it is, you have to implement, you have to devise your protocol, you have to standardize it, or you have to do the closed implementation, whatever. But with the SDN, you can program the system so that it supports the functionality you require. That's it. You are done with it. So that's the main driver behind the SDNs, I suppose. So the open way to talk to any hardware, yeah, they can maybe, but there are open ways that are sort of semi-obscure, not a semi-obscure, but semi-used, like SNMP or whatever. But you still have to use the vendor-specific systems. So the OpenFlow, I would believe there will be a vendor-specific extensions to the OpenFlow that in the end. But it's a totally different approach to the network. That is a driving force behind the SDNs.
Yeah, I'll just like to add that the bandwidth on demand that is kind of a SDN where user goes to website, selects the interface and adds the bandwidth, VLAN number they need, and then creates a circuit. We can support that on all the routers that we have. We're using APIs. But looking at the usage of that compared to what we get for the similar circuits, the manual request is a little bit still higher. So it depends on the users and maybe educating the users as well what we have set up. Mostly we see it in the software-defined networking and all is very well defined in data center environment, but in the wide area network, it's still probably just going to remain the point-to-point circuits as it is today. We have it remains to be seen, but yeah.
From the net SDN out of the data center into the core network perspective, I would believe that the Autobahn is not an SDN because it's not the software that really defines the network. It is a human that goes to the website and asks for something. And it's not the way it has to be in general. Well, it's an old talk. It's an back to the ATM days talk. But it really should be the software that should signal the network that what it requires.
Yeah.
Yeah.
They use bandwidth on demand service with their software. It's Edinburgh University. The project is called Bonfire. I don't know much details, but we are supporting this project, and they reach Dante bandwidth on demand through our bandwidth on demand testbed. So I know for sure that they have some software which requests bandwidth on demand connection.
Open Cloud Exchange could be the one as well. It's just real.
It's a similar thing we are currently doing in LHC1. There's a working group which is looking at. So in LHC1 there's a working group which is looking at how the applications that Atlas and CMS experiment use can talk to the network directly and request bandwidth on demand circuit even across Atlantic. So NodeNet, SafeNet, Giant, ESNet and Internet2 are involved in it. We hope to do a demo in next few months on that. But the point is the networks I believe are ready. It's the applications where it's gonna take a lot of development to talk to the networks API and request the resources that they need.
Any last comments to this topic? Okay, then I would say thank you to the panel and thank you for all of you participating in this. I hope you could use it for something. I definitely could. So thank you very much. The final part on the agenda is that I should wrap up. The wrap up is more about the dinner tonight. I have here the directions for the dinner. It's at a restaurant called El Tapio. I think it's of Spanish stuff. So and the dinner is at 7:30, not 9, 7:30. Sorry, sorry about that one. So thank you for today, and yep.
I think that the wrong metro station was indicated because when you take the next metro station, it's much easier to get there.
Well, you can do that if you dare. Uh,
have a hotel at the first metro station.
Yeah, that's true. Yeah, it's up to you. I have some maps here, and any of you not joining the dinner tonight? Wow. Anna, have you? Sonja and Rob? Okay. So thank you for today. See you at the restaurant later. And yeah, so thank you.
Thank you.